Okay, so today we're going to be talking about Avogadro's law, which focuses on gases. So there are four basic properties of gases, and these two, pressure and temperature, are constants, which means they don't change in his formula. And these are a part of Avogadro's law. So, there's a direct relationship between volume and amount of moles, which can be described in this. Volume is directly proportional to the amount of moles. And you can make an equation out of this, but you just need to multiply it by a constant. So volume equals a constant times the amount of moles. And also it can be written as V over N equals the constant. So I'm going to show you a sample problem using this formula. So, what size container do you need to hold 0.0459 moles of nitrogen gas at STP? So you know that STP is standard pressure and temperature, so that's the formula's way of giving you that the pressure and temperature are constant. So you know that you can use Avogadro's law here. So we also know the constant that 22.4 liters per 1 mole is for gases, and since this is a gas, we can use that constant. So then we can go to V equals constant times the number of moles, which is 0.0459, and it's asking what size container, so that's going to be the volume. So volume equals 22.4 liters per 1 mole, that's our constant, which we have there, times 0.0459 moles. So then if you just multiply that out on your calculator, you'll get 22.4 times 0.0459, and it'll give you 1.02816. Oh, and you can also cancel out the moles so you get liters, and with sig figs that will be 1.03 liters. So that's your answer. The volume is 1.03. Okay, so now we're going to do another sample problem, but this time we're going to use two situations. So if we go back to the formula of volume over number of moles equals the constant, then we also know that with two situations, the volume of one over the amount of moles of one will equal the volume of another container over the amount of moles in that container. Because it's a constant, so you can relate these two into this one situation. So let's do an example using this formula. A flexible plastic container contains 0.860 grams of helium gas in a volume of 19.2 liters. So what we get from that is that volume is 19.2, so V1 equals 19.2 liters, and we get that N1 equals 0.860 grams from here of H2. Okay, and then the next sentence. If 0.205 grams of helium is removed without changing pressure or temperature, so that tells us that the pressure and temperature are constant, what's our new volume? So what we're looking for is V2. That's our unknown variable, and they've given us this number, but it says if it's removed. So what we have to do to find N2 equals original minus amount removed, and that's going to give us N2 because they want the end result. It's not this number. So that if you plug that in, 0.86 minus 0.205, it's 0.655 grams is our N2. So now we can use the formula that relates these two situations together of V1 over N1 equals V2 over N2. And if we rearrange this problem, then we'll get that V2 equals V1 N2 over N1. So now if we use that, we can plug in this, this, and this. Well, you get that. Okay, so we get V2 equals 19.2 liters multiplied by 0.655 grams over 0.860 grams. And then the grams cancel out, and you just plug and chug. So you plug that into your calculator. Let's see. So 19.2 times 0.665 divided by 0.86, and you should get 14.8 when you use sig figs, and that's in liters. So there's your answer. So that's Avogadro's law. Thanks for watching.